Let's be real. When an AI makes a decision that could affect your life, how can you be sure it's the right one? Today, we are prying open the lid on the infamous AI black box to figure out how these things actually think.
Okay, just imagine this for a second. An AI scans your X-ray and gives you a diagnosis. It's a huge moment, right? Your health is on the line. But can you trust it? How do you even begin to question it if you have no idea how it came to that conclusion? That's the problem we're digging into.
And this gets us to the heart of it, the black box model. It's pretty simple, actually. We know what goes in this case, the X-ray, and we know what comes out, the diagnosis. But everything that happens in between, that maze of calculations and connections, it's a total mystery to us. And that is a huge problem, especially when the stakes are high in fields like medicine or finance.
So, what's the solution? How do we crack open this box? Well, there's a whole field dedicated to this, and it's called XAI, or Explainable Artificial Intelligence. Its entire mission is to invent ways to make these mysterious models, well, explain themselves.
To put it plainly, XAI is all about getting answers we can actually understand. It's about building a bridge from the AI's complex logic to our own human way of thinking, so we can finally look at the machine and ask, hey, why'd you do that? And get a response that genuinely makes sense.
So how does an AI actually do that? It's not like it can just sit down and chat with us. It has to show us its thinking. We're going to check out two totally different ways it can do that. You can think of it as a showdown, the highlight versus the what if.
First up, we've got the highlight approach. This one's pretty straightforward. It's all about getting the AI to point to the stuff it thought was important. These methods create something called saliency maps, which are basically pictures that show us exactly where the AI was looking.
Yeah, think of it like a weather map's heat map. You lay it over the original image, and the brightest, hottest spots are the areas that screamed, "Pay attention to me," to the AI. It's a super direct visual way to see what mattered most. But as we're about to find out, just knowing where it looked doesn't always tell you the full story.
Now, there's more than one way to make a heat map. Two of the big ones are called LIME and SHAP. LIME is kind of like asking a simpler mini AI to explain just one decision. SHAP is a bit more intense. It uses some fancy math from game theory to figure out exactly how much credit each little piece of data gets for the final outcome. But the goal is the same: highlight what's important.
So, does it really matter which one you use? Oh yeah, big time. Researchers put this to the test on financial data, trying to predict which companies were a credit risk. And just look at this. The image on the left, using LIME, is a total mess. High-risk and low-risk companies are all jumbled up. But look at the right, using SHAP. It's night and day. Two clean, separate groups. The difference is crystal clear.
And this isn't just about making a prettier picture. This has real-world impact. When they took these explanations and used them to actually predict company defaults, the SHAP features, that's the orange line there, were just plain better, more accurate. SHAP was clearly doing a better job of finding what truly mattered.
Okay, so pointing at things is useful. And we know some ways of pointing are better than others. But it kind of leaves you with this nagging question, doesn't it? Knowing where the AI is looking, is that really the most intuitive way for a person to understand why? And that brings us to our second approach.
Get ready for approach number 2. The what if. This is a whole different way of thinking. Instead of just highlighting what's already there, this method shows us a kind of alternate reality. It shows us how things could have been different. The fancy name for this is a counterfactual explanation.
So what on earth is a counterfactual? Well, it's an explanation that basically answers the question, why did this happen instead of something else? The way it works is, it takes the original input and then it generates a new version of it, showing you the absolute smallest change it would take to make the AI change its mind. It's not about what is, it's about what could have been.
Okay, you have to see this, because this is where it gets really cool. On the left, you've got an X-ray that an AI said was normal. Now look at the image on the right. That is not a different person's X-ray. It's the AI's own creation. It took the original image and changed it just enough, adding that little bit of haziness in the lungs to show you precisely what it would need to see to call it pneumonia. It's literally showing you the tipping point.
And the researchers who came up with this said it best. They said these explanations directly show how the input image would have to be modified to alter the AI's decision. You see the shift? We went from where did you look to how would you change your mind. And that just might be a much more human way to think about things.
So now we have our two big ideas. We've got the highlight versus the what if, saliency maps versus counterfactuals. But which one is actually better? For regular people trying to figure out what an AI is thinking. Well, to find out, researchers set up a really clever experiment.
Here's how it worked. They brought in 118 people. No doctors, no AI experts, just everyday folks. They showed them a bunch of x-rays, and their job was simple. Guess what the AI decided. But here's the twist. Each person got a little helper. Some got a Lyme heat map, some got a different kind of heat map, and some got that cool counterfactual image we just saw.
All right, this is the moment of truth. Which group was actually able to get inside the AI's head? Which tool turned out to be the best guide for understanding the machine's logic?
And the results? Wow. They weren't even close. The people using the heat maps, Lyme and LRP, they only guessed the AI's decision correctly about 56 to 58% of the time. I mean, that's barely better than flipping a coin. But the group with the counterfactual images, they were 79% accurate. That is a massive, undeniable difference.
But wait, it gets even better. It wasn't just about getting the right answer. This shows the human side of all this. The people who saw the counterfactuals said they were way more satisfied with the explanation. They trusted the AI more. They felt more confident that they understood what was going on. They even felt more relaxed and less angry while doing the task. The whole experience was just better.
So the verdict is in, and it is crystal clear. For people who aren't experts, seeing how an AI could change its mind is so much more helpful than just seeing where it looked. The what-if story is just a fundamentally better explanation for us humans. And that leaves us with one last big question to chew on. As AI gets woven deeper and deeper into our lives, our health, our jobs, our money, it's pretty obvious that just getting an answer from it isn't going to be good enough. The real question is, what kind of explanation are we going to demand? Will a simple highlight be enough, or will we expect a story of what could have been?